Hello, everyone. Welcome to the Challenge 1 walkthrough for Summer of Spin. You'll see that I have open the repository on GitHub for Challenge 1. We'll be making our way through this README in just a moment. But yeah, let's dive in. I want to first, so I have cloned the repo and I'm inside of the Challenge 1 directory. And just to make it easy, I'm going to just generate a Go HTTP template because our application requires us to receive HTTP requests. So I'll run through that, name the application challenge. Yes. And so we'll see that we have our challenge directory here. I'm going to move all the files out of the challenge subfolder just so we can have access to the WebAssembly module that we pre-created for the encryption module. So, oops. Okay, right on. So if I jump to my VS Code, you'll see that I have the challenge 1 directory, and we've got our new files here just with our HTTP initialized. And then it gives us our spin.toml, all that. So the templates are pretty nice to use. Anyway, let's start going through this, shall we? So just to recap, the scenario is that you are the head coach of a summer soccer team, and you have a book of plays that you want to keep safe from the other teams to make sure they don't have access to the names of your plays. And so, but before you had a chance to add the final name of the last play, you encrypted the playbook. And so what we've provided is an encryption module that will allow you to decrypt the playbook so you can add the final name of the play to the string, re-encrypt it, and then move on. So we've got a couple of set of instructions. We've got instructions for our main app here, and then down here, we've got instructions for interacting with our encryption module. Excuse me. So first things first, we're going to be building a spin app using the encryption module as a component. If you're not aware, these WebAssembly components are pretty handy. So I wrote the WebAssembly component in Go and compiled that into a WebAssembly binary. And what's neat about it is you can integrate that module into your spin applications. And they don't actually have to be in the same language that I wrote the applications. You could write it in Python, Rust, whatever other language, and just make HTTP calls to it. And it will work just the same. So pretty neat feature of spin and WebAssembly. Anyway, so we are going to configure our spin application to receive an HTTP post request containing the binary data of the encrypted string from plans.txt. So we'll decrypt it, that string, and then we'll append the code name we came up with to the end of the decrypted string. We'll re-encrypt it, and then we'll return this HTTP response. Yeah, so let's just start there. I'm going to pull up my VS Code. All right. So back to our main, in this case, main.go or whatever language you're using, your main file. I am going to just remove these guys here. So first things off, we need to read the body of our request. So oops, equals, oops, all r.body. And we've got our standard Golang error response. Okay, so just to recap, we are reading the request body and getting the UTF-8 encoded bytes that were sent with that body. So Moving on to the next portion, we need to actually read what was sent. So let's just do a quick print line. Call this request. So this will just show us what was sent to make sure we can double check that our plans.txt was read properly. So once that was read, we are going to move on to making a request to our encryption module, decrypting it. So maybe before we jump into that, let's move to our spin.toml and just define the different routes to our encryption module. So you'll see that here we have our main.wasm file. This is the WebAssembly binary I mentioned before. Right here, we've got the source code for that. So what we need to do is define a module that will allow, an HTTP trigger that will allow our spin application to interact with this WebAssembly module. So let's jump over here first and create our trigger.htp. We'll define our route, which is the URL that this will be accessible at. And we wanted to do that as crypto. We'll call this component name crypto. And then we'll define our crypto component source. So source. And we just want to do the path to this file here. So I've got that over here. I'll just copy that over. And that should, also with making outbound HTTP requests, even if it is to a module within the spin application, you are still required to define an allowed outbound host for it. So that's easy. We'll just do HTTP localhost 3000 or 127.1. Yeah, I'm not remembering which one that is. I think the other possibility is, I think I've got it down here. I think it's 127.0.0.1. Yes, it's 127.0.0.1 is the other one that you can do instead of localhost. Okay. So we've got our spin.toml navigated. This kind of defines the structure of our spin application. And so we've got our allowed outbound host. We've got our source for the crypto component and our route. So we should be good to move on to making requests to that. Jump back. Okay. So first, we will just create an HTTP request. And we're going to do a GET request to the crypto module. Let me double check that that is how I set that up. Interacting with the encryption module. So it looks like when I make a curl request, I just have GET. So we'll define that as GET. The URL is going to be what we define in our outbound host, HTTP. And then we'll do /crypto because that is the route we're going to use to interact with it. And then we just need to forward the bytes that we read from our request that we received onto the crypto module. So we'll do bytes. And we'll just do a quick copy and paste because it's going to be the same across the board. So now we have our HTTP request defined. And you'll notice in the, let me jump back to the README here. When we make a request to the crypto module, they ask us to define this x-action header. So because we're trying to decrypt the string, we'll set that as decrypt. What we do, we'll set that as x-action. So that sets our header, and we should be good to send our decrypt request. So decrypt response. Call that RSP. Now with Golang specifically, we need to use Spin's built-in HTTP module. Just make sure that you're checking your language guide for sending HTTP requests because it will vary language to language. So now we have that. We're just going to do the decrypt request. We'll paste that. And then, so we've got our response, and now we just need to parse the response. Let's jump back to the GitHub. So you'll see that when we get the response back from the encryption module, we have a JSON response with these different values. This is just going to be what we sent to the encryption module, this request body header. The action type is what we defined in that header, and then the response back, so the decrypted or encrypted response. So we're going to define the structures that Golang needs to properly parse the JSON. So let's call this type crypto response. We had our request body, which need to define our JSON. Action type. These aren't necessary. These first two aren't necessary for the actual application to function properly, but it's just helpful to have for debugging. This response, is going to be important for us, though. That's what we need to retrieve. Okay, so we've got our crypto response structure defined. And now all we need to do is we're going to read this. So we'll say we're going to say decrypt response.body, right? So we are grabbing the decrypted bytes from our decrypt response, we'll paste in our error message, and from there we're going to create our JSON. Decrypt bytes, probably. Yes, that's right. Okay, just to go over what's going on here. We are creating a variable that is this type, so that will hold the data structures properly. And then we are just parsing out these bytes and placing them inside of this structured type so that we can access the data later on. So now that we have this data placed inside of our crypto response variable, let's do a print. Just so we can see what we got when we decrypt that. I think this is probably a good spot to just see what we get. So jumping back over to my terminal, I'm going to do spin up. This just has to be in the same directory as my the file we've been working on. So we're going to wait for that to build. And while we wait, if I'm remembering right, we've got one more structure that we need to pay attention to. So this guy, our body needs to return this. So let's create, while we're waiting for that to build, one last structure. We'll call it response. This will just allow us to write this response. Oh, no, that's wrong. It's got to be encrypted message. Is that right? Encrypted message is what that needs to be called. All right on. Let's check on our app. Looks like we're getting there. This really is taking quite some time. I'm worried something went wrong with my code. Oh, no, looks like that's building. Okay, we're good. No, whoops. Okay. So we're going to curl our application, and we need to make sure we're including our plans.txt, just including the binary file that we have. Oh, wrong repository. Well, apologies. Give me just a second more. All right, try this once more. Okay, so you'll see we made a curl request to our localhost 3000, and these last two logs show us our request payload. If we're just to double check, that starts with LE, it ends with equals equals. Just make sure we got everything. LE equals equals, looks good. And then this is our decrypted message. Play 1, Operation Kino. Play 2, Aldo Rain's Masterpiece. Play 3, looks like we just need to append our the name for our play. So let me jump down to here, back to our application. So now that we've got those taken care of, let's go ahead and name our secret play. Name ours Gourmami. And then let's create the new message. We'll do decrypt JSON dot response plus secret play. So that should take care of our secret message, our completed playbook. And so now what we need to do is make another request to our crypto module and ask it to re-encrypt this string. So let's do encrypt request dot new request. We'll do get. All right, so just to recap, what I did was created another HTTP request and then just converted this new message string into bytes, because that's what our HTTP request requires. And then I think I need to recopy this. So we've got our request created. Let's quickly add our header. So do encrypt. Header.add. I think we did set. We'll do set. All right, so we've got our header set. Let's make our request. All right, so we've got that taken care of. Let's take care of our error message as well. And now all we need to do is read our encryption message. So read all, and we'll say encrypt response.body. Get our error message. And we'll make sure to defer that. And then, now that we've got that, let's do what we did up there and create our JSON And just a refresher, this is us placing the bytes that we received back from the crypto module and parsing them into the structure we created up here, or struct we created up here. So now that we've got that taken care of, let's create our response. And I am just, once again, using this guy here, just so that we're getting an encrypted message in JSON returned when we write our HTTP response to the terminal. So we're going to call this one encrypted message. And then we'll do encrypt JSON dot response, right? Because that's going to give us back the re-encrypted message. Now that we have that, we are good to start building our HTTP request. So I'm going to, let's just take a gander at that requirement. So we need to have our content, we need to have our response code. So HTTP status okay. Our content type needs to be application JSON. We need to tell them the name of the play and the path to our encryption module. The primary reason for these is just so that the HURL tests that we created have a chance to just validate to make sure that the stuff was properly encrypted, decrypted, all that. So let's go ahead and create our header. This is our HTTP response. And then we'll do w.header.add content type. Our secret play. What did we call that variable? Oh, whoops, just because I'm outside, that's why. All right. So I made a mistake there. Yep, so I've got our encryption module path that we need to define. And then all we need to do is write a response. So we'll do if oh, shoot. I forgot. So we have our JSON here. We need to just convert that into bytes that can be read as JSON. So we'll do if oops, doing that wrong. JSON.Marshall will do response JSON. Let's copy this guy. All right, so that should take care of that. We've got our response byte JSON Marshall, and now we can do response bytes. Okay, this wraps up our code portion. So let's just go over this just to make sure it's clear. We've got our different structs. This is for the responses we get back from the crypto module. And then this is for the response we're sending back. We read the request that is sent from the curl request from the user. We make we forward that payload data to our crypto module here. We decrypt it. And then we append our secret play. We make another request to our crypto module, re-encrypt it. And then once we get that response back from the crypto module, we parse it and write our response back according to what the README required from us. That should cover everything. Let's jump to our terminal real quick. And then let's build our thing again. This will take a moment, so we'll wait for that to load. It'll take quite a while, doesn't it? Okay, right on. So now that this is complete, let's make our call request. Okay, right on. So we've got an encrypted message. We can run the Hurl test to check, but I think what would be a little more informative would be for us to do this, and then we're going to do H, create our header. So sorry, I'm going to explain this. We're going to curl our crypto module directly and just see what we get back. So X action decrypt. Okay. So this looks like this worked properly. We've got our request body, our action type, and then a response. Play 1, Operation Keto. Play 2, Aldo Rain's Masterpiece. And play 3, Gorlami, which looks like it matched. So according to the README, in order to properly validate this, we need to run a Hurl test. So Hurl test, test.hurl. Oops. And we can see that everything ran successfully. Hot dog. So yeah, that wraps it up for the walkthrough of Challenge 1. Hope you guys enjoyed it.